Well, hi and welcome to my shop, and thanks so much for coming and joining me here. It's January 24th. So I think I've reached the point now with this radio where I believe it's largely working. It could be virtually 100% in terms of resistors, capacitors, voltages, all that stuff. So I think it's time to start turning attention towards its performance. And I think a big part of that is being able to measure its performance. So what I would have to do is inject a signal of known strength, maybe into the antenna, and then be able to monitor the result, usually in the speaker or maybe on the AVC line. And from then on, as I make changes to the radio, I think it's mostly going to be alignment anyway, I'll be able to see the improvements to it. So there's a couple ways of doing this. I'm not sure which one I'm going to take. Maybe I'm going to take all of them, measure voltages and stuff like that. So the thing is, here's an interesting thing. So I've restored the -10 bias right now with this clip lead. Without the -10 bias, it looked like the bias on two tubes fell to -1 volt or so. They're looking for -10. They're getting -1. That's not nearly as much bias. That means the quiescent current passing through the tube would be much higher than it would have been had the -10 been there. And I've operated this radio for 40 years in the condition it's in. 40 years without that wire. 40 years and thousands of hours. I use this radio a lot, maybe not so much in the last year or so, but certainly in the past, hours and hours on this thing. And I'm looking forward to doing hours and hours on it too in the future. So what that means is those two tubes with the incorrect bias have been working extra hard during those 40 years. The question is, did they wear out? Did they wear out ahead of other tubes? So here's my tube testing chart. These are all the tube tests here. The tubes that were weak, I circled. There's one circled here, 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 and here. 4 tubes I thought were weak. Maybe I should think about changing them. One in particular was quite weak. The 2 tubes involved in the problem with the bias. One is tube number 11. I'm going to have to double check this before I make this statement here. 7. Whoops. V7, 2500. V7 is a 6BA6. So a really good 6BA6 was 4100. So I'm circling a BA6 at 2200. Now, the purpose of these 2 tubes, V11 is a very important amplifier tube. It's actually it's the tube that receives the output of the IF and then controls it or prepares it for entry into the detector. You can put it that way. So I think you'd want a strong tube there. And V7 is something called the 455 something or other. So I started looking for a good point to pick off the AVC voltage, and of course in this radio everything is quite complicated compared to a normal radio, and that, as desired, has driven me into in a detailed way into part of the radio, in this case the AVC circuitry in the radio. I've read the write-up here. The AVC write-up goes here, here, and all the way down to here. All that is describing what's going on in this circuit. I think I got a grip on it. So I think what they're doing here is, first, this is the AVC rectifier tube. It's rectifying signals coming out of the IF through this capacitor here. This capacitor is blocking away some DC that's going to develop in the AVC circuit on this capacitor, and it's also making sure that this supply doesn't leak back this way. How that would happen, I don't know. So here we have 150 volts coming from the part of the power supply that has the regulator tube on it. So it's pretty sure it's 150 volts here. Goes through a resistor voltage divider, most of the voltage is dropping here, and what you're left with is 27 volts positive sitting on the cathode of this tube. So this tube will not conduct until the plate becomes more positive than the cathode. So the plate has to be more than 27 volts positive for any conduction to occur. And at that point, any conduction will increase the charge on this capacitor and increase the AVC voltage. Increase it or produce it. Maybe produce it is the right word. When there's no conduction in this tube, I'm not exactly sure what the AVC voltage sits at. So maybe we'll find that out in a bit. This part of the circuit is showing the tubes the AVC voltage is going to. You can see when you have it flipped on AVC, these tube grids are delivered a voltage from this circuit here. Only if this is above 27 volts. And so what this is making me think is I better check all this. I mean, the AVC circuit is a really big part of what makes a radio sound the way it sounds and work the way it works. And although certainly the AVC works in this radio, is it working ideally? They changed the AVC capacitance here on this switch. When you switch, this is showing it on CW, so this would be like Morse code. So Morse code is, of course, a transmission with breaks in it. It's not a continuous transmission with a little bit of signal on it. It's a come and go, come and go. It's quite a different thing. So the AVC, if it's set up for your typical listening to somebody talk, probably won't work all that well when you're trying to monitor Morse code. So to help it, when you flip to CW, an additional capacitance is switched in along with this one. So now you have more capacitance in the system. Slows the AVC down, so the radio in between the dots, the radio doesn't come up in strength. It stays down in strength and sensitivity, and you'll get a nice clear Morse code. You won't get it in between the Morse code beats. You won't get coming up. I can't imitate it. No, I'm not a radio. I can't imitate it. My radio does not contain this, but this shows you where you would tap off to get the AVC to do other stuff with it, mostly to drive other radios and equipment. This is so this particular radio can work in conjunction with other pieces of equipment. I don't have this on mine, no, but this is one of the places where you would pick up the AVC voltage and stick it on your meter here. If we look at these resistances here, they're not all that large, and the big resistors are back here. Well, I guess maybe it would depend upon what kind of meter you put on. If you put on a low impedance meter, you might have trouble reading this without affecting the radio. That's the whole thing, is you got to read the voltage here without affecting the radio. Pretty sure a VTVM anywhere in here is going to be just fine. And this is also a capacitor that's going to affect the AVC speed. 0.01, 0.25, and that's what's that? That's 1,000 picofarads. It's a 0.001. So that's quite small. This is pretty small. This is really big. Okay, is there anything else I need to look at? To show you other radios have differences in their AVC circuits here. So we're going to study this because this is another radio, a different version of this radio. Okay. Well, I think the name of the game then is I need to find and check these two resistors. Or run the radio and check this voltage. Pin 5, didn't I do that? Pin 5 of V14, I would have done this. Okay, this looks like good news here. Here's my tube voltage readings, and we're looking at tube 14, and we're looking at the pin 5, which is the cathode right there. So the expectation on this table is for 22 volts. Now, is this table my radio? I don't know for sure. The actual reading was 20. 20. I had something else here and scratched it out. RF gain minimum or maximum. 20 instead of 22. But I got 27 in my head. I got 27 because that's what's written in this document here. 27. Here we are, 27 volts. They call it the delay bias. 27 volt delay bias stuck on the cathode of that tube. I need to check that. If I need to check, I can check the two resistances perhaps, if I can find them. I think it's probably easy to find. Okay, I'm going to go hunt down the area in the radio where all this circuitry exists. Okay, let's take a look at what we got here. Oh, okay. So this is V14, and what we're looking at is pin 5. So come around pin 5. 1, 2, 3, 4, 5. And there's a resistor there, it goes to ground, and a resistor here. This resistor I have replaced in the past. That's pretty interesting. So that's my resistor. This one down here doesn't look like I replaced it. These are the two we need to measure and figure out if they are correct or not. What are they supposed to be again? These are 100K and 18K. Let's just take a look and see what they actually say first. Well, it's K. It's obviously been warm. Colors are shot on it. So that one, that's the one that goes to ground. So that should be 18K. So that should be, where'd it go? Brown, gray, orange. Okay, and then this one, this is supposed to be the 100K. Could be. The first band looks funny, but I think it's probably brown, black, yellow. 100K. So, okay, 18 and 100. Are they? Are they really 18 and 100? Can I do these in the circuit here? Just taking a quick look. I think I probably can. I think I can. I'm going to use, let's see. And 100. Okay, so we're on the 200K scale. Not that it really matters. Okay, the first resistor, this will be the 100K guy. This isn't going to get to 100. Be lucky if we get to 50. Half. Still in the circuit though. Okay, and the other resistor is supposed to be 18. Let's see what we get here. Close. 15. 18 and 100. So if we made it 20 and 100, then it would be 20 of 120. That'd be roughly like 15%. If 15% of 150 volts would be the same as 15% is 30% of 300. 30% of 300 is around 100. What the heck did I just? I don't know what I just calculated, but it was fun doing it. So I think I'm going to renew those two resistors and make them proper. Now, is that really a smart thing to do? Why wouldn't it be a smart thing? Because the resistor values I'm looking at in the manual here aren't what's in my radio, and I'm about to switch them incorrectly. I'm going to study that just for a little bit before I do this change. So I have the replacement resistors ready here, but I checked my pin resistance measurement done on this tube, on this pin right here, the one in question with the two resistors hooked up to it. It's supposed to be 16K and it measured 17K. Very close, measured basically correct. So I'm thinking probably the resistance measurements I took, especially on the 100K where I got 50, probably from circuit interferences here. So I'm going to lift this off. If I'm going to replace it, I have to lift it off anyway. I'm going to lift this off. I say I'm going to lift it off. There it goes. There we are. Now I'll measure it and I'll probably find out it's 100K like it's supposed to be, and I don't need to replace it. Okay, here's my meter at the ready. So I see 106 on the meter. Slightly high. The other one reads differently now. Right. Okay, so it's reading 16, and it's supposed to be, what's it supposed to be? I've forgotten already. 16, 18, wasn't it? 18. 16, 18. I think in this case, you know, I think I might as well replace these with new. Then I know for sure what the resistances are there. So I'm going to go ahead and replace them here. So I've cut the second resistor free here so we can get a better measurement on it. Just for interest's sake, it's going to go now anyway. It's supposed to be 18, 18, 18. What happened here? $16. So it is a little bit low, almost 17. That's not much, but it could be in this particular position. It's really quite critical. Everybody happy there on that terminal? I think so. Okay. Now, did I put the right resistors in? 18 down below and 100K up here. Okay, we're on. Got a reading. 0.02. That's right. So that pin should read 16. Oh my gosh, it's right on 16. Resistance measurement for that. So this is pin number 1, 2, 3, 4. Pin 5. Tube what? Tube what number was it, Jeff? I can't remember now. Crying out loud. There's just too many numbers in this world. 14. So we come down to 14. Come across to 5. This is supposed to read 16 and I'm reading 17. But now I'm reading 16. I'm reading right on the money because I replaced those resistors. That's excellent. Let's throw the switch, see what happens here. Nothing, 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 and nothing. Okay. Okay, AVC meter, ground disconnected. We have the speaker, the audio system still connected so we can hear this when we start up the radio. The AVC, it should be reflected on this meter over here. Don't know what to expect yet, but obviously it's got to be above the 27 volts, so it's going to be a fairly large number. So we're on the 150 volt scale, negative. That's good. These switches should be in. This should be in AVC, and this should be in modulation, like they are. Everything is ready to go. Just looking everything over quietly. We want this meter on. So this is going to be measuring the audio output, this meter. And this one would be the AVC. Once we get to that point. Okay, I think I'm ready. Put the headphones on. Headphones on. Okay, control panel volumes up. Pretty noisy on this one. We are hooked up, right? Yep. Yep. Okay, we're ready. Well, we're not ready. Volume down. AVC. So this is on. As soon as I hit the power, she's going to go. Power is set low here. Let me set it up roughly where it should be. 117 volts is what's going to be fed, but first I'll have the dim bulbs in, so it's not going to be 117 to start with. Are we ready? Here we go. Ooh, exciting. Dim bulbs are dim. Very good. Up a little bit. Okay, we're trying to run the radio on 85 volts here. The heaters are quite slow. When you reduce the voltage, the heaters can be really slow to come up. What's happening on our AVC meter? Nothing. For some reason, this meter, well, this meter sits like this normally when it has no signal on it. This is a dB meter. It doesn't have a zero. There's no zero. Well, we're not hearing anything. I think it's just a low voltage. Here we go. There we go. Now we hear it. Let's see the sound level coming up. Okay, so this meter is doing the right thing. Could be the hum that you hear and other things are holding this meter up. So that hum could be not from this radio, we don't know for sure. Okay. It's going, so AVC voltage showing nothing over here. Absolutely nothing. Hello, hello. So we're going to feed a signal into the radio now and make the AVC come up. Gotta hook up. Signal generator output is low. Running the output through this box. This is an antenna simulator. There's a blocking capacitor in there and a little high circuit. Gives the radio the feeling it's hooked up to an outdoor antenna, while giving the signal generator the feeling that it's hooked up to a 50 ohm load. That's the whole idea. Make those guys feel nice. So you want to input the signal. Oh wait a minute, I don't need to use this. This is a much better way. I have a cable. So I have a cable right here. Set it up already. Forgot. Okay, we don't need to clip the tight cable. Careful, man. Careful. So this is going right to the antenna coupler on the radio. Her little pop there on my speakers. So we're down in that broadcast band, but really the radio is. Let's set it to something nice. Right in the middle, 6 megahertz. So the radio's tuned to 6 megahertz. It's a single conversion. And so we want to get 6 megahertz. We want to get 6 up on here. 6, 8. Very low signal level. 6. Okay, so a lot of radios wouldn't hear this at all. I'm going to go down even lower. That's really impressive. Really, really impressive. To me. 6. 7. 8. 9. 10. 11. 12. 13. 14. 15. 16. 17. 18. 19. 20. 21. 22. 23. 24. 25. 26. 27. 28. 29. 30. 31. 32. 33. 34. 35. 36. 37. 38. 39. 40. 41. 42. 43. 44. 45. 46. 47. 48. 49. 50. 51. 52. 53. 54. 55. 56. 57. 58. 59. 60. 61. 62. 63. 64. 65. 66. 67. 68. 69. 70. 71. 72. 73. 74. 75. 76. 77. 78. 79. 80. 81. 82. 83. 84. 85. 86. 87. 88. 89. 90. 91. 92. 93. 94. 95. 96. 97. 98. 99. 100. 101. 102. 103. 104. 105. 106. 107. 108. 109. 110. 111. 112. 113. 114. 115. 116. 117. 118. 119. 120. super sensitive radio. I can't get this down even. I could vernier it down lower, but so that would be 0.1 times 10. That'd be 1 microvolt right now, roughly. Roughly 1 microvolt. Listen to it. That's great. Let's just make sure. So now we want to see what happens to that AVC voltage. I'm watching the meter, it's not moving at all. But 1 microvolt may just not be enough to overcome the delay. So I'm going to jack up the input signal here by a factor of 10. Do you see the meter pop up? Another factor of 10. It'd come up a tiny amount. I'm on the 5 volt scale. Go up another factor of 10, another factor, another factor. Well, that's a whopper of a signal being fed into the back of this radio now. Isn't that amazing? The actual tone or signal level stays pretty much the same. You can hear the noise going up and down in the background. It does get a little louder, but I guess it has to get a little louder, right? It can't. There's a logical problem with it being perfect. You know, when you're using governor type approach, sort of. Well, we didn't get any AVC voltage. But surely the AVC is working. Clip lead problems. Why? I'm fiddling around the clip leads now. Certainly got it on the terminal I was aiming for. Okay, I'm going to turn off AVC. I saw the meter bop just a wee bit. Turn it back on. So this is, now that was interesting. This is the CW. So the idea of this is it switches in an additional capacitor. Now it could have, when the capacitor first goes in, it has to charge to some point. No, yeah, it sounds different, doesn't it? It shouldn't sound any different, I don't think, once everything's charged up. So I'm very suspicious I have a wiring problem in the AVC switch. Okay, so this is manual. I'm going to turn the RF gain up. That's 6 on the numbers. Up, 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 up. That's full. RF gain is full. I'm going to flip it back to AVC. Hear the difference? A wee bit more of the AVC. The meter popped up just the tiniest amount. So what we're finding out here is either, well, I don't know if we're really finding anything out, but what we've observed is apparently no AVC voltage action. I can't believe that. That's not believable. Okay, I think I got it right now. I had it on the wrong spot. I got just a little confused there. Can you blame me for getting confused? Okay, so I'm clipping this. Well, who else can you blame for me being confused but me? So now I'm on the right location. I'm pretty sure. Maybe a very small. There we are. So I'm on the negative. Oh, over here, everybody. I'm on the negative here. So upscale is a negative voltage. A tiny voltage there. 15 volts. What's going on in the radio now? Okay, so, whoa, whoa, whoa. Okay, so I'm going to watch that AVC and see if it varies as I move this. Hot diggity dog. Okay. Okay, so this is a valid location. Does it interfere with the radio? I'm going to connect and disconnect. Let me hear a thing. Not even. It's perfect. So that's our AVC connection there. We have the audio meter. There. I think we're set. So the first thing we want to do is try to establish the overall sensitivity of the radio at this point. So I want to put in a known voltage and measure the output on my meter. This is a proper audio output meter, a 600 ohm meter. It's on a 600 ohm output along with the 50,000 ohms or whatever it is in my audio thing, which shouldn't matter. It should be in a calibrated situation is what I'm saying. We need to calibrate my signal generator at this point. So let's do that. To calibrate it on the band and roughly the frequency we're going to operate at. So we'll stay right on the 6 megahertz frequency or so. And this has to be up full. This is the adjuster. Put it on 10. 10 times the multiplier. 10 times 1, 10 microvolts here. Is there really 10 microvolts at the radio? Well, that's a tough one. So if I want to vary the output now, I leave the calibration alone and use this. If I want to fool around a bit, I always return it to the max. Put this back over here. 400 hertz modulation. Modulation is at 30%, 35%. There it is. We're all set to go. 10 microvolts. Now, I gotta find some information about this. I haven't even done that. Okay, I gotta hunt down some information here. So here's a page in the manual which just covers the specifications on the radio. And something interesting here to note is 130 watts. I got an email from someone, thank you for sending me your emails, mentioning that their radio runs around 90 watts. This one is running around 150 watts, or was. You know what? I can check it. We are on full voltage here, 118 volts being supplied, and the wattage is 124 watts. Okay, I dropped a bunch of stuff on the floor here. 124 watts, so not bad. So here it is, sensitivity. I don't know what that is. MEW. Something CW. MCW. 2 microvolts or better on CW, 0.75 microvolts or better. A signal plus noise to noise power ratio, oh boy, that's a mouthful, of 10 to 1 at a 3 kilocycle bandwidth. Okay, it's like a few caveats in that statement. We could just go and say you should be able to get a 1 microvolt signal coming through fairly clearly would be impressive, I think. Signal plus noise to noise. Yeah, people often talk about the signal to noise ratio, but it's actually signal plus noise to noise. 10 to 1. I would even measure that. You need some kind of equipment or a technique to do it, to become aware it's 10 to 1. But what they're saying, a signal ratio like this, I would think, what they're saying, just very, very simply, the signal sounds 10 times louder than the noise. And I don't think that's true, because we don't hear things linearly, right? We hear them, whatever the word is, non-linearly. Okay, so I think basically, as long as the radio's receiving at 1 microvolt fairly well, it's working fairly well. That's where it is right now. There's a few other things here worth looking at. Line fuse 1.6 or 3. It's 1. I have a 2 amp fuse in here now. Crystals, ambient temperature. Oh, just freezing. It's pretty hot though. Just freezing though. Output, okay, 600 ohms. Headphones, 8,000 ohms. Oh, I stick an 8 ohm headphone into this thing all the time. This circuit will operate satisfactorily with headsets ranging from 600 to 8,000. Well, it also works with 8. IF output. 70 ohms. So that's on the back of the set. Maximum undistorted power. Antennas, lead-in, weight, 80 with the cabinet. Rack mounting. So that's mine. 66 pounds. So every time I'm picking up 65 pounds. Okay. So I think that's about all we're going to get right now on sensitivity. 1 microvolt, and we've seen. Well, let's listen to it again. Or have you been listening to it all this time? Put my headphones down. No, you're not. Let's get it going here. There it is. Oh, have a look at the radio. Okay, so double checking our signal generator settings. Times 1. We calibrated at 10. So there's 10 microvolts on the radio right now. We're taking down to 1 microvolt. Well, that's tricky to hear, right? Would you say that's a 10-to-1 ratio? We're doing this on the sensitivity they suggested, 3 kilocycles. How much lower can you go? And you still know it's there. Is this calibrated enough that it can do something like replace a couple of weak tubes and see an improvement? Am I in a position to do that? I'm here. I have to leave everything absolutely alone except the tube that I want to change out. I can do it, but I can just pull the tube out and put the new one in. I'm going to have to turn the set off. First I gotta find the tube. There it is. I have 2 excellent 6BA6s. I want to change V11. V11. I believe it's V. This be it. Here. Okay, now I gotta put this one in. This is the scary part. Pulling it out is not nearly as scary as putting it in. Make sure the pins are all straight. And I've had situations where I put tubes into operating radios and the pins have actually managed to short against tube sockets and stuff like that. So this is not the safest thing to do here. I get right around, get a look. Oh, it's too dark. There it is. I see the gap. We're going in. Right in. Okay, we're right in. This is the brand new 6BA6. Come on, radio. Here it comes. Right, put the voltmeter back on, which fell off. Okay, so interestingly enough, the AVC voltage is exactly the same. The audio, on the other hand, has disappeared. So I'm going to tune the radio a bit. This shouldn't have affected the tuning. Not at all. Now, let's not be fooled. The output may be lower, but the signal to noise ratio may be much better. So again, this is 1 microvolt. I think it's better. I wonder what that hiss is we're listening to. Are we just listening to the radio itself? With that hiss? It must be the case, huh? Okay, so changing the tube did nothing. Now there's another bad 6BA6 I want to change. Let's just go through that. That was V2. Oh, wow, that's right in the... oh yeah, let's do that. V2. I'll put the other strong one in. What did I do with that weak one? I took it out and I put it back. Uh-oh. Oh yeah, it's still warm. The other strong one is here. Where'd it go? I see it. Trying to make an escape here. Couldn't do it. So we're going to put this one in the V2 position, which is the second RF amplifier. Okay, we'll do it live again. Do it live! That's my Bill Riley imitation. Bill O'Reilly, I guess it is. Bill O'Reilly. Okay, I need my glove. So this is V2 coming out. Pop. Now that's interesting because you hear the hiss we're hearing. So there's less radio now. I've taken away the two front, the effect of the two first tubes by pulling out the second tube. First tube doesn't matter. So now we're listening to the rest of the radio. Hey, that's kind of interesting. Oh, I shouldn't have done that. I guess the AVC voltage has gone up a bit. Why would that be? There's no signal coming through. I kind of messed up by fooling with the volume, but let's go ahead and put in the right tube here. Put in the new tube. What a dirty tube it is. That looks beautiful now. Okay, on we go. Why would the AVC voltage go higher? Nice. Idea. I'm going to look right inside that tube cell. How am I going to do that? Audio wires coming off here. So this is hooking up the meter is introducing noise and a hum. Okay, what am I doing? I'm putting this tube in. I'm trying to put this tube in. That's what I'm doing. I'm going to look down in the socket to see where the gap is. It's a long ways over there. So I keep whacking my... let's drop this down. Okay, I'm going in. Oh, there's not enough light. Okay, another try. see the gap. Right in. Bingo, right in. So mess everything up here. Friends. AVC's up a little bit. Now, it's not because I monkeyed around with the radio. I may tune it. No, still tuned that on. So, we got more signal. And as for audio, well, we have more on the meter, but I messed around with the volume control. Now, signal to noise, what do you think? Any different? I wouldn't say so. So it's just 1 microvolt. Okay. Now there's a couple other tubes, but they were oscillator tubes. I'm going to switch those later on my own this afternoon. Just come in and switch them. Find a couple of good 64s and stick them in there. So if the local oscillator is really weak, then the resulting product coming out of the mixer tube is also weak, and so getting a stronger local oscillator might boost everything up a little bit. Maybe. What to do now? Why don't we listen to? Let's listen to a little bit of radio here. We have to go throw the switch. So this is the radio without any signal input. There's nothing hooked up to the antenna at all. So all we can really be hearing is the radio and maybe the tiniest little signal making it in the front. So I think the hiss we're hearing is the radio hiss. In case you're wondering. So now I'm going to hook up the outdoor antenna here as soon as I find out what I did with it. Here it is. Our ears don't get blowing off when I put this on. I think we're around 6 megahertz, aren't we, right now? What will we be hearing here? Well, I just noticed the AVC voltage had gone way over scale. So now we've got 15 volts. 2 to 3 volts on there. But we're not going to hear anything down at 6 megahertz this time of day. Maybe at 7. These are ham radio guys doing Morse code. Yeah, you might think Morse code, that's gone. Oh no. No, no, no. So that's some more ham radio there. This is a digital system called FT8, FT4. Ham radio operator. I don't think the BFO is working here. Here it comes. Oh boy. Good. It's working. band. Now we're switching to double conversion. So everything could change here completely. Let's just, there could be problems in the double conversion part of the radio that I haven't really paid attention to yet. Okay, so we're up at just above the hand band here. See if I can clarify this. It's not strong enough. Not for while I'm demonstrating the radio. Yes. Try that. I think there's a bunch. So part of what I'm doing there is I'm testing the BFO to see if it's functioning the way it should. It seems to be. Seems to be. Let's move on to some. There's lots of hand stuff in here. Let's move on. This is the international broadcasting in Europe.
Of what it is, you know, all things work together.
Oh, there's another meter here we should have been watching all this time. Stupid me, I didn't. This one.
But when you believe on Christ Jesus, as the scripture have said, God simply cannot lie. And all things work together for good. Perhaps today you cannot see that. And undoubtedly last week, even yesterday, you didn't see it. But all things work together for good. But if thou faint in the day of adversity, thy strength is small. So run on.
Beautiful.
Run on and save yourselves from this untoward generation. And you are
see the signal fade on the meter here. So this meter is doing exactly the same thing that this one's doing. If you have an AVC, if you have a signal strength meter, you have an AVC meter on your radio. You don't need to hook up an external antenna or external meter. You can use this if they're hard up for stuff. You could align this radio using this. It sounds like Arabic. Okay. So when this radio is working well, as you kind of fly it through a band of stations, you hear really nice. It's really nice. Let's do it for fun. Here we go. Oh. So there's a kind of a whir sound there. You hear it now? There's a hiss and then there's a. What is that? Goes away with any amount of AVC voltage. Okay, a real strong station. We're going to go down. First, I'm going to do WWV here.
becoming more than 6 miles. Light slow. Port wall. Valid from 24. Gusting 22 knots. Visibility more than 6 miles. Few clouds at 18,000. Becoming between 2000 Zulu and 2200 Zulu. Wind 280 degrees, 12 knots.
So that's obviously a weather information station broadcasting just around 10 megahertz, probably somewhere here in Ontario, not far from here. I don't think I've ever heard that before. Okay. BFO is definitely working, but no WWV going on. Okay, now that's Morse code. The BFO turn on. You hear the tone. That's what the BFO is really all about. And the strong station is 9330. There's a blocker here. Okay, let's watch the AVC. And you listen and watch. It's 5 volts. In the wrong way. Hope I don't get a copyright hit for that. See, until you hit a bit of a signal, this is just as rock solid as can be.
Se ha cruzado muy bien Jordi. Balón atrás para la ronda de Araujo. Con Sergio Busquets, que bien ha hecho el manejo, que bien ha hecho con la cintura, que ha dejado con el molde a Lucas Boyé. Balón que le va a caer en banda derecha para Dembélé. Quería encarar a Mojica. Deja para Busquets. Busquets para Jordi Alba. Ahora sí con otro tono el Barça. Buscando más, teniendo...
Probably South America, but I don't know. I don't know about that one. Very, very quiet, other than the signals. Beautiful. Oh, that's unbelievably quiet. And we're, well, okay, here comes the strong one. There we go. This is not particularly strong. Maybe down here.
Really began at even, then the
this is the strong
of any date is when the date begins, not ends. So if the day began at even, he would have said, in the 10th day of the month at even, from even to even, shall ye celebrate your Sabbath. But he didn't. Instead, he said, in the 9th day of the month at even. So obviously, the evening of the 9th was still considered part of the...
So I've seen that meter I just showed you go all the way up to 90 with strong stations. Not recently, but in the past. It doesn't seem to want to get much beyond 60 right now. So I think that's an indication that something's not quite right, and it could all be alignment at this point. And that's a good question. Is it time to start doing the alignment? The alignment process is going to force me through more circuits too, just like I did with the AVC here. Yeah, because I don't know what else to do now, really. I think everything's good. I still have the wire to make permanent here. Great, okay, so we're coming along fantastic. Alignment, yeah, I think I'm going to start working on the alignment. We'll see you on the next video.